In this lecture, we're going to build an array-based list. But before we do that, I think it's important to ask ourselves why. Because you'll remember halfway through the previous lecture, we actually ended up with something really nice, a nice linked list that we called a dlist. So dlists had some wonderful properties. If we wanted to add items, remove items, get items, all of them were fast. And I also said that we avoided ugly special cases by having the special topology where the empty list looks something like this, and as you fill in items, you end up having a structure like this. I'm not going to go back over it. And you'll have a chance in Project 1A to see just how this beautiful idea makes it not so hard to code up. At least, to me. For you, you might have a little more struggle. That's okay. But once you get the ideas down, you'll realize, and I hope appreciate, how good it is. So all of these operations are fast. The data structure is pretty beautiful. So the question is, why bother? Why bother using arrays instead? And so let's talk about a limitation to lists. So in general, if you have a list, a lot of times you want to be able to get a specific item out of it. So we might be able to ask a list something like, could you get me item 2? So I'd say get item 2, get 2, and it would return 17. So it turns out with this linked list implementation, it's going to be slow for long lists. And what I mean by slow is if you compare the performance of the get operation to the performance of get last, it'll take a lot longer. So I'd like you to think about why that might be the case and for what inputs. So ponder that for a moment and I'll spoil it. Okay, so the reason is that you have to actually scan to the desired position. So if I want to get item 2, I have to follow the Sentinel link, hop a couple of times, and get the 17. So while that's not so bad here, imagine you have a list that's 1,000,000 items long, and someone asks for item 500,000. No matter what, you're going to have to end up scanning all the way through the list, and you'll reach the point in the middle finally and be able to return the item. But it means you have to walk a really long list, which is going to be slow compared to just getting, say, the last item. So how can we fix this? Well, I didn't actually make this slide blue and make you think about it. There's some ways you can maybe ponder it, but the two most obvious ways, or the two most natural ways, is one, the thing we're going to do, which is to use an array instead, avoiding the need for any links. Because without a bunch of links, there's no need to traverse them, and that'll make it fast. And there's another approach we'll discuss much later, where we can mess with the topology of this list in a very clever way and end up with something that's a lot faster. But we won't discuss it today. So let's move on to the array list then.